Okay, now we've counted a pendulum, and we got some number of counts per minute at two lengths. Lengths were 1 and 3. 1 chalk box, 3 chalk boxes, right? Now on this scale, we went out to 4, subdivided that, divided that interval from 0 to 4 in half, got 2, divided each of these intervals in half and got the 1, and we got the 3. We're going to do the same for the 160. We divide that in half and we get 80. We divide the interval from 0 to 80 in half, we get 40. We divide the interval from 80 to 160 in half and we get 120. Yeah, those aren't completely even. They kind of get shorter as they go up, so try to make them as even as you can. I have the disadvantage of having to look at this from strange angles. Okay? And I'm not being all that careful just because I don't want you to feel bad. Now, I'm going to put down 2 points. So what are to get? Observed. Let's just say, for comparison, that I observed 147 counts per minute at length 1 chalk box, okay? Where am I going to put a point on this graph that corresponds to that? Everybody see where it ought to go?
You go right one.
I mean, presumably, this is something you learn in elementary school and probably use. There's a lot of stuff you learned in elementary school that you never used again that you've probably forgotten, like how to do fractions. Okay? Yeah, just give you a calculator. Yeah. It's going to help thinking about what fractions mean. Okay, so we got length of 1 here, right? And we got a count of 147. Well, 147, well, halfway between 120 and 160 is 140, right? And then if I subdivide that, I get 130 and 150, and 147 is probably going to be about here. And 1 is here, so I'm not sure I went all that straight, but it's going to be okay, right? So now I've got a point in my graph. Okay? Well, you've got 2 points to put in a graph, so sketch your own graph and see if you can locate those 2 points. Now, you don't need to pay attention to what I'm doing up here. I'm just going to put another arbitrary count down. Might or might not be accurate. 82 counts per minute, length 3. So, 82. Okay, I'm just going to take a quick look at what you got. Draw this kind of quickly. You don't have a lot of time, so you don't have to do your final, most accurate version. Just draw a couple of points that more or less depict what you observed or what you think you observed. Your graph will look a whole lot like mine, but it'll be more accurate for you using an actual calculation. Okay, that looks good. Looks like everybody knows what to do. Don't see a problem. Okay? Now, what do you think, based on this graph, what would your estimate be for length 2? What do you think the count would be? You probably think it'll be between 82 and 147, right? Because it seems like the longer the pendulum gets, the slower it, the less frequently it swings, right? And that's certainly the way things go. It's what physics predicts and what's common experience confirms. We're used to that idea, if we pay attention, right? Easy to test. Next time you take your shoes off, just hang one from a shoestring and oscillate it, hang it from a shorter shoestring, and you get the feel of it. Okay, so where do you think the point corresponding to a length of 2 would lie? Think it'll be closer to 80 or closer to 147, or halfway between? Okay, but we're going to vote on this. Okay? How many of you think it'll be closer to the 147? Okay? How many think it'll be closer to the 82? How many think it'll be halfway between? And how many of you didn't raise your hand? So I want everybody to signal closer to the 147, closer to the 82, or halfway between. Right? This, or this. Okay? So let's see, we got, okay, oh boy, I got to go out now. Let's see. Okay, 1, 2, 3, 4. Okay. And we got 1. And we got, how many people are here? 21, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can see 19. Okay. So we don't know. Okay, now, I mean, yeah, we got votes, and the tendency of the vote is slightly that it'll be more than halfway between, right? The point will be more up here than it'll be down here. But most people think it'll be about halfway between, which means that if we drew a straight line from here to here, well, since this is halfway between these, then this point will tell us what's halfway between this and this, right? There's some simple geometry of similar triangles involved here, but we won't get into that. Okay, so that would predict that we're here. Now, according to my graph, which is not going to be overly wonderful, it looks like, let's see, this would be 90, this would be 110, looks like 117. But halfway between 82 and 147 is 119 and a half, isn't it? So my graph isn't totally accurate. Are you surprised? Well, no, it's a hand-drawn graph, bad perspective with a fat piece of chalk. What do you expect? Okay? Reasonably close. So my estimate would be like 117, really halfway between would be 119 and a half, right? Okay? So, let's see, that means that, okay, if the graph is a straight line, then if I extend the x-axis out to here, what does that point tell us? What are the coordinates of this point? Take an estimate. What's the x-coordinate of this point? Give you a hint. It's more than 4. I think most of you saw that. Okay? You're kind of cheating if you understand numbers, but okay. Okay, so you think it's, how many think it's more than 5? How many think it's less than 100? Still processing the question? Most of you aren't raising your hand, so I don't know about you, but okay, fair enough. Okay? More than 5, but less than 100, right? That's what you think it is, like 50?
Like 5.5.
Yeah, there's 3, there's 4. So 5 would be here. It looks like a little more than 5, right? Okay, well that would correspond to 5 what? It's 5 what?
Chalk boxes.
Chalk boxes, right? How long would that be? Well, that'd be down to about here, right? Can I make a pendulum that long? Well, I'd probably need a little more thread, but yeah. Okay? Okay. Okay, what's the count for that point?
0 per minute.
Sorry?
0 per minute.
0, count 0. Okay, that means if I make a pendulum this long and pull it back here and let it go, it'll just stay there. It won't go, it won't oscillate. Right? Is that what happens? What's that tell you about a straight line model? There's a contradiction. Okay? Now maybe it really is straight between here and here, but then somehow gets curvy or does something. Okay? But most things don't behave like that. They usually don't go straight to curvy. Okay? So maybe there's a problem with the straight line model, but maybe not. We don't know for sure what happens between here and here, but we know it's not going to do this, right? We know, in fact, that within the lengths that we can talk about, it's never going to give us a 0. Okay? Now it might be long enough that it oscillates really slowly and round less than half a cycle per second and rounds off to 0, but it's not going to be 0, right? That's an important thing to think about. Okay. So this point would mean length 5.3, count 0. It doesn't really make sense if you think about what the graph is telling you, right? So I'm pretty sure it's not a straight line graph. Well, there are other things I ask you to think about this, and this is what's going to be due on Thursday. Okay? You've already got a graph. Now, I probably want you to draw, if you got a graph that you think is good enough, probably want you to draw it a little bigger. Okay? And of course, if it's going to be bigger, it's going to take you a lot longer, right? Well, no, not really. Okay? Won't take you 2 minutes to draw the same graph, but mark it off carefully, draw it a little bigger. Okay? And then there are things that I ask you to do, and you're going to have to read and do them. Okay? I might not ask you to do the whole. There are a lot of words there. Yeah, and 2/3 of the words tell you to do what we just did. Okay, so there are a lot of words that tell you to do stuff that doesn't take all that long. Okay? But the thinking part, spend a little time thinking and processing this thing. Make sense? Okay? Okay. Okay, well, let's talk about something a little different. Then I'll tell you a little more about the course. And we'll get a little mathematics under our belts so you understand better what I'm telling you. There are more than this, but less than this, fewer than this. Basic graphs that you have to understand, graphs of basic functions, okay? And you have to understand them like right away. Like by next week. And I observe that there's a strong correlation between the people who mastered this task in a week, which is a very reasonable time, and those who completed and passed the course in the last 2 semesters, last 3 semesters. in my class, okay? So you want to make sure you really do this and get it right, because we use it throughout the semester, okay? And I really, nationwide, less than half the people start a pre-calculus class finish it, okay? And it's running, in my class, is about 50%, which means I'm a little better than the national average, but we want to get it up, okay? But it requires a lot of work. So be prepared to do the work and start doing the work right away and doing a good job of it, okay? And think about what you're doing. You'll see more about what that entails as we go on. And as I said earlier, make sure that you review the algebra and stuff, okay? So let me just ask you a couple of questions about very basic arithmetic. And these are questions that, in my experience, at least 70% of people coming into a pre-calculus course can't answer correctly. Okay? And this is due to a lot of things, the SOL thing that I talked about, using calculators to do simple arithmetic. I mean, you got to use calculators to do some things, right? What the square root of 943? Well, I can tell you it's about 30.4, but it could be off by a couple of tenths. Okay? You're going to use a calculator if you want an accurate result. So tell me, write down on a piece of paper, what's the value of 2 to the negative 3? Okay, at least half the class hasn't written anything down yet because you got to think about it. Okay? Well, what's the definition of a to the negative b? This is one of your laws of exponents. Anybody tell me? Certainly somebody knows. I'm thinking maybe 30% of the class kind of knows. I'm seeing none right now, but I think some of you know, you're just afraid to say. Okay? Maybe all of you know, and you're just waiting to see if I do. Right? Okay, let me think. Okay. This is 1 over a to the b. Now that's one of the laws of exponents. It's fundamental. You learn it in Algebra 1, and you actually learn it in pre-algebra, but nobody seems to be able to use it. So this is one thing that you just have to remedy. You have to know the laws of exponents and how they work. And as I say, I don't have time to teach you this. I have time, but you don't have time for me to teach you this and not to teach you pre-calculus, right? So you got to get this. Okay, well, how do you apply the law? How does it apply to 2 to the negative 3?
Plug and play, like algebra.
I'm sorry?
Plug and play.
Yeah, you plug in. What do you get if you plug in?
You get 1 over 2 to the third power.
Yeah, exactly. I think everybody pretty much sees that. If you don't, look at it until you do. Okay, so that's like 1 over 2 to the third, right? Now, what's 2 to the third? I'll give you a hint. It's not 6 because I see that a lot.
8. 8.
It's 8. 2 to the third means 2 times 2 times 2, right? 2 times 2 is 4, and 4 times 2 is 8. That's 1/8. Okay, another one. What is, don't say it, write down what 2 to the 0 is. And put a circle around it so you can see it. Okay. I've seen a lot of right answers and I've seen a lot of wrong answers. What is any number to the 0 power? 1. Is 2 a number? Yes, it's any number to the 0 power is 1. 2 to the 0 is 1. Okay? Now again, the fact that probably about half and half, whether people know this, coming into a pre-calculus course tells me that people need to be sure they understand the things that everybody in the rest of the world understands when they come into the course. And everybody would. Any place else in the civilized world, everybody starting a course at this level would know these things. And would ask, why are you even asking me that? It's so obvious. Okay? And if you want to catch up with the rest of the civilized world, and we are behind it, then we need to get these things straight. Okay? It's a serious. And it's doable. You can do it. Just be sure you do, okay? It's not some moonshot. It's just do what needs to be done. Take some time, but not that much, and get it straight. The premises that we build mathematics on, okay? And again, you probably didn't need to know it for the SOL, so it didn't get used that much. And you probably used calculators, and the calculator gave you an error. Well, not for that. The calculator told you 1, and you just accepted it without thinking that there's a reason for this, okay? Because that gets you through an SOL, and that's what our schools have to do, okay? Okay, so you gotta fix that. You gotta fix that, but you can, so please, please, please do. Okay. What's 1 over 0? Write it down. Now, I'm not paying any attention to who gets it right and who doesn't. I'm just looking at percentages. Okay? So what do we got here? Okay. Some of you got it, some of you haven't. Let's think about what this means. Let's just think about what's 10 divided by 5? 2. Why? Because 2 5s make 10, right? So if you got 10 things, you can split them into 2 piles with 5 in each. So the 10 divided by 2, 5 is 2, right? So what's 10 divided by 2? You take those 10 people or 10 objects and divide them into piles, you're going to get 5 piles, right? Okay? Now, 10 divided by 5 is just exactly the same thing as 1 divided by 1/2, isn't it? Like you can ask, how many 5s are there in 10? Well, there are 2, right? How many halves are there in 1? 2. How many times does 0.2 go into 1? 5. You can count 0.2, 0.4, 0.6, 0.81, right? How many times does 0.1 go into 1? Yeah, 1 divided by 0.1 is 10, not because your calculator tells you so. There's a picture for it. And if you don't understand the picture and don't think of the picture when you're doing it, you're not thinking division, you're just writing down numbers that your calculator tells you. And we're not going to use calculators in here very much at all, I think I mentioned that. And we're certainly not going to use graphing calculators, not hardly at all.
Good, mine's
Okay?
broke.
Huh?
Good, mine's broke.
It's a good place for it. May they all get broken.
It was very expensive.
Huh?
It was very expensive to be broken.
Well, I hate that for you.
I bought it 2013, last time I came here.
Yeah, that's a pain. Hope that doesn't happen to too many people. I'm sorry it happened to you. Okay. And that happened the day after the warranty ran out, right? Okay. Well, that's why they're designed, isn't
I
it?
gotta return those textbooks.
Got to make
Since
profits.
like the
Well, I don't think
70s?
so. I think they designed them pretty well. But
See ya.
I've got calculators. I got solar calculators from the 80s that are still working.
That's the same calculator though, isn't it?
Huh?
That's the same calculator. They've not updated it. It's my understanding. It's basically the same one.
Anyhow, okay. So there's a reason that something divided by something is something else. So how could you figure out that 0.1 goes into 10, it goes into 1 10 times? You could count 0.1, 0.2, 0.3. Yeah. Okay? That makes sense? Okay. How many times does 0 go into 1? That's what 1 over 0 means, right? How many times? Huh?
None. 0.
No, because if you have 0 zeros, you don't get 1. But if you got 10.1s, you do get 1, right? So 0 zeros doesn't make 1, so 1 divided by 0 is certainly not 0.
It's still 1 because it's not being divided by anything.
Sorry?
Is it still 1 because it's not being divided by?
100 zeros still doesn't make 1. Can't
Yeah,
divide by
yeah, well, how many zeros do you need to make 1?
all of them.
10.
All of them, that's a pretty good
You still
answer.
can't make 1.
I like that. I don't think I've ever heard that one before. I like it. All of them. Okay. Well, for all those reasons, 1 over 0 ain't. Okay? So that's some basic arithmetic that I shouldn't have had to spend 15 minutes telling you about, but I got to tell you about some things. Because these are things that you've probably never had to think about because you do all your arithmetic with a calculator after you're 6 years old in our school system. Very bad idea. Okay? But you can fix it. You can still think about numbers, right? Okay? Okay, well, good.